Welcome to my channel, and today our topic is EMF of the cell and single electrode potential. This is the third video under the electrochemistry series. Okay, so in this topic we are going to discuss about the EMF of the cell. It is called electromotive force of the cell or cell potential also sometimes we can call. So and another concept, single electrode potential. These two topics we will discuss in this video. Before starting the topic, you need to recall some basic terms. So already these terms are explained in my previous videos, Electrochemistry 1 and Electrochemistry 2. The links are provided in the description. You can follow those. So for better understanding of this topic. Anyway, I am going to describe these terms in simple way. Oxidation means losing of electron by a substance. So reduction means gaining of electrons by a substance. At anode, always oxidation takes place. At cathode, always reduction takes place. And electrode potential means when a metal dipped into its own ions, it has two types of tendency, whether it is loses electron or it gain electrons from the electrode. That tendency is called potential, electrode potential. If it is loses electron, that is called oxidation potential. If gains the electron, it is called reduction potential. Okay, so and finally, electrochemical cell is a device which produces electricity by performing redox reaction. So what is the electrochemical cell? It is a device which produces the electricity by performing redox reaction. Redox reaction is nothing but oxidation reaction and reduction reaction. Oxidation takes place at anode, reduction takes place at cathode. That means at anode electrons are generated. Oxidation means losing of electron. That's why at anode electrons will generated. That electrons are required at cathode. Why? Because at cathode reduction takes place. Reduction means it accept electrons. To acceptance, its need electrons. That electrons are provided by the anode. So this potential difference create the electricity. So what is potential difference? First of all, question is what is potential difference? So when you touch hot teacup at morning time, you feel very hot. Okay, definitely you feel very hot. Why? So the Copeak of temperature is higher than your hand temperature. That's why heat transferring from high temperature region to low temperature region. Okay, in the same way, high altitude to water moves to lower altitude place. So those are spontaneous reactions. Okay, and here also, so if you observe the first diagram, so here so many electrons is there. So in left side ball there is so many electrons is there. Here no electrons is there. So higher electron density is there. So now when you connected these two, electrons are freely moves from high density electron density to lower electron density side. This is called potential difference. It's when the charge separation occurs. That means when some side positive charge, some negative charge is there, always positive and negative wants to meet each other. So it is a spontaneous process. So when the charge separation occurs, there is a potential difference occurs. It creates electricity. Why it creates electricity? If you observe here, so the monkey wants to connect two positive ions each other, but it is not possible. So it is working hard. That means it is a non-spontaneous reaction. So you can see in the downside here another diagram. So someone is pulling positive ions from the negative ion. So he is doing work here again. So he is doing work for 30 joules or something. How much work? 30 joules work he is doing. So when you leave the positive ion, they spontaneously come and attach the negative electron. So that means it is a spontaneous process. It releases energy. The energy in the form of electricity. So that's why when the potential difference occurs, it produces energy in the form of electricity. So the same thing is happening in our electrochemical cell. So anode producing electrons, at anode oxidation taking place, anode producing electrons. These electrons are required at cathode. Why? Because copper plus 2 accept electrons and converting into copper. It's required electrons. That's why these electrons are moving from anode to cathode. So it's generate the electricity. So it is the potential difference occurs between anode and cathode. It's generate electricity. So electricity is because of oxidation potential of anode plus reduction potential of cathode. EMF is the combination work of anode and cathode. When anode involved in oxidation, it releases electron. But without cathode, these electrons will not move from anode. Even though anode producing electrons, to move the electrons from anode to cathode, cathode is required. Why? Because cathode required electrons, it full of the electrons from the anode. And the same way, cathode required electrons, but without anode, that electrons will not come to cathode. So this is the combination work between the anode and cathode. By definition, it can be stated as it can be measured by combination of oxidation potential of anode and reduction potential of cathode. That means how much anode oxidized and how much cathode reduced. The combination work is called electromotive force of the cell. Or it can also measure difference between the electrode potentials of the cathode and anode. That means electrode potential taking as a same term. That means either a reduction potential or oxidation potential. Don't worry, I will explain this, somewhat confusing here. So for example, if a metal having oxidation potential X, the same metal having reduction potential equal to minus X. So it is a formula, oxidation of potential of metal equal to minus reduction potential of metal. The same way, reduction potential of metal equal to minus oxidation potential of metal. So we can write the definition as per our statements. Oxidation potential of anode plus reduction potential of cathode. Electromotive force of cell is equal E oxidation of anode plus E reduction of cathode. Okay. So just replace the oxidation potential of anode with the reduction potential of cathode. So what we have the formula here, we want to keep reduction potential of anode instead of oxidation potential of anode. Oxidation potential of metal is equal minus reduction of metal. So I am replacing oxidation potential with minus reduction potential of the metal. So just oxidation potential of anode is going to reduction potential of anode with negative charge. So that's why that the definition converting as a E reduction potential of cathode minus E reduction potential of anode. So now this can be in words we can read difference between the reduction potential of cathode and reduction potential of anode. So it is very simple. So there is no confusion. Just look at the numerical problem for better understanding. So standard oxidation potential of anode, that means zinc, is 0.76 electron volts. So what is standard oxidation potential? Oxidation potential at standard conditions is called standard oxidation potential. Standard conditions means at room temperature 25 degrees centigrade. If you dip zinc rod in 1 molar zinc sulfide solution, then the oxidation potential of metal is called standard oxidation of anode is equal to 0.76 electron volts. So here you can see E naught standard can be represented with naught. So E naught of zinc by Zn plus 2. Zinc by Zn plus 2 means zinc is converting into Zn plus 2. So zinc 0 is converting into Zn plus 2. This is a oxidation. So that's why oxidation potential is equal to 0.76. But I want to write reduction potential of same metal. That's why I am converting Zn plus 2 to zinc. So if Zn plus 2 is oxidation, Zn plus 2 to zinc is reduction. So to write reduction, just keep a negative value, negative sign before the 0.76. It's becoming as a reduction potential. Okay. The same way, standard reduction potential of copper, that means cathode, is 0.34 electron volts. So reduction potential means G plus 2 to Cu is equal 0.34 electron volts. So but if I want to write oxidation potential of copper, how can I write? So just keep a negative charge. So here negative is missed. Actually here negative is there. So oxidation potential of copper is Cu by Cu plus 2 mean oxidation is equal minus 0.34 electron volts. So like that we can interconvert the oxidation potential into reduction potential into oxidation potential. Just remember the formula. oxidation potential of metal equal to minus reduction potential of metal. So now, so according to our statements, E naught cell is equal oxidation potential of anode plus reduction potential of cathode. Combination of oxidation potential of anode plus reduction potential of cathode. Just add two things. Oxidation potential of anode. Oxidation potential of anode means this one. So 0.76. So and reduction potential of cathode. This is the reduction potential of cathode 0.34. If you add 1.1 electron volts, this is the first formula. You can check the second formula also. Second formula is difference between the reduction potential of cathode and reduction potential of anode. So difference, that's why is a minus is there. So reduction potential of cathode doesn't change, 0.34. Cathode reduction potential is 0.34. So there is a minus, so I keep the minus. And reduction potential of anode. So all they give the oxidation potential of anode 0.76. We can convert it into reduction potential by keeping minus sign. So it is minus 0.76. So that minus 0.76 I substituted here. Minus into minus become plus. So finally this is also give the same result. So you can use both definitions, but frequently in the textbooks or in notation every time we are using this second formula is used much times. Okay. So E cell is equal E naught of reduction potential of cathode minus reduction potential of anode. So E naught, if they didn't mention any oxidation potential or reduction potential of a metal, that means someone give the problem. In that problem, electrode potential of metal is equal 0.1 electron volts. So what is that potential? Oxidation potential or reduction potential? If they don't mention anything, you has to take it as a reduction potential. This is the you have to take like that only. Okay. If they don't mention whether it is oxidation potential or reduction potential, you has to take it as a reduction potential. And generally used formula to measure the E cell is equal E cathode minus E anode, or E naught cell is equal E naught cathode minus E naught anode. Here we are not mentioning oxidation or reduction, that means it is reduction potential only. So this is the generally used formula. So this is the EMF. EMF is nothing but the cell, how much electricity is produced, the capacity of the cell, the potential of the cell. So this oxidation reduction potential, a combination of oxidation and combination of reduction potential is called EMF of the cell. So it's clear. The next thing is, so as I told, this is the combination work. It is a teamwork of two electrodes. Without anode, no electricity. Without cathode, also no electricity. So it is a teamwork between the anode and cathode. So this is the anode giving electrons, and this is the cathode taking electrons. Both combinedly doing the work. That's why electricity is producing here. But after producing electricity, they are discussing, anode and cathode discussing, so how I worked, I am greater than you, or I work more than you, like that some discussion is coming. So how can we derive, how can we know the single electrode potential? So EMF is the combination work. So how much electricity is produced can be measured by using voltmeter. So when you construct a cell, you can measure the current of the cell. So by using voltmeter, it gives the combination work of the cell. But I want each single electrode potential. That means anode how much it oxidized, cathode how much it reduced. That is called single electrode potential. Single electrode potential is nothing but the electrode potential corresponding to single electrode is called single electrode potential. So for example, EMF of this cell is equal to electron volts. That means one cell producing 2 electron volts energy. Then what are the individual electrode potentials? So we know E cell is equal to electron volts. E cell means oxidation potential of anode plus reduction potential of cathode. So for example, oxidation potential we don't know, just take it as a X. Reduction potential of cathode is equal to Y. Both combinedly perform and they produces 2 electron volt energy. Then what is X? Then what is Y? Can you measure the X value numerically? without knowing y? X is equal to 2 minus y. If you know the y value, then only you will find the exact x value. In the same way, if you want to measure y, y is equal to 2 minus x. Without knowing x, you cannot find the y. So it is impossible to determine single electrode potential without fixing one of the electrode potential. So to read the x value, you definitely need to know the y value. The same, if you want to know the y value, you just know the x value. That means one of the electrode potential must be known before constructing electrochemical cell. That known electrode is called reference electrode. The next topic, so we are going to discuss about what is reference electrode, what is the significance of reference electrode, types of reference electrodes, construction and working of reference electrodes can be discussed in the next topic. Until bye, thank you for watching my videos.